So getting started with chapter 21, it's titled Solving Inequalities. And the good news is that by having already solved several equations and learning the procedure of solving equations, you pretty much know how to solve inequalities. There's just a few extra rules that we need to learn when dealing with the inequality symbol um, instead of the equal sign. Okay, so chapter 20, we learned about how to orient the inequality symbols with respect to positive and negative numbers. We learned how to graph inequalities. And so we also learned that we can reverse the direction of the inequalities if we reverse the left and the right hand side. So let's get started with 21. Example 1 wants us to determine whether the following numbers are solutions to the inequality. And that's one thing that you need to realize about inequalities from the start, is that a lot of times when dealing with equations, we end up with one solution, okay? Or at least with the equations that we've dealt with so far, with the exception of the equation that's called an identity, where basically we have two expressions. For instance, 2x plus 1 equals 2x plus 1. The left and the right hand side are identical, and this is an identity, and the solution is all real numbers. Solution, all real numbers. Okay, so it's sort of like that. All we want is for this quantity in example 1 on the left to be less than 38, and that depends on what we use for v. So what happens if we plug in a 0? 5 times 0 minus 7, is it less than 38? Well, 5 times 0 is 0, so we get negative 7 less than 38. And that is true. A negative number is always less than a positive, so 0 checks out. Now what about 19? 5 times 19 minus 7. Is it less than 38? Well, 5 times 19 is a 95, and then we subtract 7, which is an 88, and that is not less than 38. 88 is bigger. So 19 is not a solution to our inequality. What about negative 10? With a negative 10, the left becomes 5 times negative 10 minus 7. Is that less than 38? Question mark. Well, 5 times negative 10 is negative 50. And if we subtract an additional 7 from that, we get negative 57. And a negative number is less than a positive, so negative 10 checks out. $30. 5 times 30 minus 7. Is this quantity on the left less than 38? That's the question. Well, 5 times 30 is 150, and 150 minus 7 is 143, which is not less than 38, and so 30 is not a solution. And finally, what about 9? Five times 9 minus 7. We get 45 minus 7, which gives us 38. And in this case, 38 is not less than itself, so this is not true. And 9 would not be a solution to this inequality. But already we have at least 2, and there's actually more. Okay, anything between 0 and negative 10 would be a solution. Okay, so there are many, actually infinitely many solutions, but not all real numbers are solution to this inequality, as we had with the identity equation. So, a bit of a difference there. Okay, so what do we need to learn about inequalities in order to apply the rules that we learned about equations? Well, for one, the idea of taking a true inequality, much like we started with a true equation when we first started talking about equations, we don't want to perform an operation that will negate the truthfulness of the inequality. So what we do to one side, we do to the other. So if we start in this case with 2 less than 3, which is true, and we perform an operation to one side, we add 1, then we must do it to the other side with the same number. And so if we started with a true inequality and we perform the same operation with the same number to left and right, we end up with a true inequality. Okay, so when we have an inequality involving variables, then as long as we perform the same operation to both sides in terms of addition, then that equation will be true. Okay, so trying to make a point here with subtraction and addition, in terms of the inequality sign, you just keep the same sign. Okay, so if you started with less than, then you keep the less than symbol. You treat it like an equal sign. You just bring the same symbol down to the next line. So for instance, if we started with 3 is greater than 0, and we subtracted 1 from both sides. Okay, we performed an operation on the left and the right, we would end up with a 2 greater than negative 1. And this inequality is also true. We perform the same operation on both sides, and this works with subtraction or addition. And so all we did is we kept everything on the left and the right to itself, and we just bring the inequality symbol down. Okay, so with example 2, keep that rule in mind, and then you just simply apply the same rules to inequalities that we learned with equations. We want to graph the solution of this inequality. Well, first we need to figure out exactly what numbers work in the place of u, not just some of them. We want to know all of them. And so to solve this inequality, we take note of what is happening to the u on the right hand side of the inequality. Just focusing on the right, we have u plus 3. What is the opposite of what's happening to the u? Well, that would be to subtract 3. And so we do that to both sides of the inequality. The 3's cancel on the right. We only subtracted, and so we bring down the same inequality symbol, and 11 minus 3 is 8. Okay, so now we have a really an accurate idea of which numbers satisfy this inequality, and those are u such that u is a number greater than or equal to 8. Okay, and so it didn't just simply want us to solve this inequality, it wanted us to graph it. So real simple, u can be equal to 8. We have the bar below the inequality symbol. But then we want u. The inequality opens up towards the u. And so we want numbers that are called u such that they are greater than 8. And so we shade to the right. And we can sort of shade the arrow too. Anything to the right of 8 and including 8, so I put a solid dot at the location of 8, would represent a solution to the original inequality, and that would be this one. 11 is less than or equal to u plus 3. Example 3, additive property of inequality with integers. So we look at our variable and we're adding 17 to it. We want to get the u by itself, just like we did with the equation. So we do the opposite and we subtract 17 from both sides of the inequality. Okay, just like an equation, there is a left and a right side. So on the left, plus 17 minus 17 is a 0, and so we're only left with the u on the left side. We were only subtracting, so we just bring down the inequality symbol with the same orientation. It opens up towards the left. And then negative 14 minus 17 would be a negative 31. Example 4, we have an inequality with fractions. We treat it just like we would an equation with fractions. We take both sides of the inequality and we multiply by a common denominator, preferably the lowest. And so here the 20 is going to multiply both items on the left, and then on the right 20 times a 1/5. 5 divides into 20 4 times, and 4 times the 1 that was on top is still 4. For the fraction negative 3/4, we would divide the 4 into the 20 and we get 5 times everything else on the top of the fraction, a negative 3, and then we multiply the 20 times the w, but the w doesn't have a denominator that will reduce the 20, and so this is just 20 with a w beside it. Okay, 5 times negative 3 can be calculated, and we get a negative 15. Alright, here is our variable. This, if we had an equal sign, we could call this a two-step equation, because with the variable on the left, we only have a 20 and a negative 15, two numbers that we need to get rid of in order to have the w by itself. So we get rid of the 15 first by adding 15 to both sides. Fifteens cancel on the left. We have 20w equals, or I'm sorry, is greater than 19. Okay, and so far we've kept the same orientation for the inequality symbol, And now we will divide by 20, both sides. And we get W is greater than 19 over 20. Okay. Any number greater than this quantity will represent a solution to the original inequality. So one such number would be 1. There are many, and so I'll just test 1. 1 is greater than 19 over 20. So if I go back over here and I rewrite the original inequality with a 1 in the place of W, then this, and I'm just calculating the left-hand side, and so the left-hand side is equal to 1/4. Okay, so 1/4 is the left-hand side when I calculate it with W equal 1. Is that greater than 1/5? Yes, it is. Okay, if you type these in your calculator and you calculate the decimal versions, then the left-hand side, 1/4, is 0.25. The right-hand side is 0.20. And so W satisfies the inequality, W equal 1. But that's just one solution. Okay, there are many. Any number greater than 19 over 20 will satisfy this inequality. Example 5, we have y on the left and a negative 5.4 being subtracted from it, basically, if we look at the sign in front of it. So to do the opposite, we add 5.4 to the left and the right hand side. 5.4 cancels on the left. A negative and a positive cancel when they're the same number. So we bring down the inequality, same orientation, and a negative 6 plus a 5.4 would be negative 0.6. Okay, so any number less than or equal to negative 0.06. And so just a few examples of some numbers that would satisfy this inequality would be negative 1, negative 2, negative 0.7, okay, negative 22.54. Okay, any decimal number, any fraction with a negative sign, as long as the number part is greater than 0.6, meaning it is further away from 0 than 0.6, will satisfy the original inequality. Okay, so if I plugged in one of my solutions that I picked out, negative 2, would that make this inequality a true statement? Well, a negative plus a negative is a negative number, and 2 plus 5 is 7, and then we tack on the 0.4, and negative 7.4 is further to the left on the number line than negative 6. And so it is less than negative 6, and negative 2 checks out as a solution to the inequality. Okay, so here are the situations where that we have to learn that are different from the equal sign. Okay, the equal sign didn't have a direction, okay, a certain orientation, while the inequalities do. And so now we see that in this situation, if we start with a true inequality, simple one, 1 is less than 2, true, and let's say I take both sides of the inequality and I multiply it by -1. On the left, I would get a -1. On the right, I would get a -2. And now, if we simply bring down the inequality in the same orientation, we no longer have a true inequality. Okay, -1 is not less than -2. It's the other way around. And so, whenever you multiply or divide by a negative number involving an inequality, then what you have to do to maintain the truthfulness of the inequality is reorient the direction of the inequality symbol. So in this case, it opened up towards the right. Multiplying by a negative number on both sides would cause me in the next line to have to open the inequality up towards the left. Okay, and that's really the only special rule when dealing with inequalities versus equations. So, if we divide or multiply by a negative number, we reorient or flip the inequality symbol. Okay, so we end up having to do that with this inequality in example 6. W is being divided by a -3, and to undo that, we multiply by a -3. If we multiply the right by -3, we have to multiply the left also. And now that we're multiplying by a negative number, okay, those two things have to be true. We have to be multiplying and we have to multiply by a negative number. Then we flip the inequality symbol on the next line. The -3's on the right canceled, and so we bring the W down, and on the left, -3 times a -10 is a +30. So anything, any number greater than, okay, the inequality statement or symbol opens up towards the W. So W is greater than 30. Okay, any number greater than 30 will satisfy the original inequality. So, for instance, if I use a 33, okay, 33 is greater than 30, so it should work. We have a -10 greater than 30. Hold on, I wanted to put 33 there. Go back and remove that. 33 over a -3. Okay, is this true? It should be. Well, -10 is greater than, and 33 divided by -3 is a -11. And so if this is unclear as to which one is actually greater, then you need to write out a number line. And remember that starting from 0, left or right, you would start with the number 1. And if you go to the left, then the numbers simply have a negative sign in front of them. So 2, 3, 4, 5, 6, 7, 8, 9, 10. And then the next number would be -11. Okay, which number is farther to the right? It would be the -10. Okay, and so -10 is greater than -11. So this inequality checks out. And 33 would be a solution to our inequality. Likewise, 34, 35, 36, any number bigger than 30. If you happen to try to use 30 itself, well, we could plug 30 into this inequality, and you would see that it is not true. So it will not be a solution to the original inequality. If we divide by negative 3, the 30, then we get a negative 10. And negative 10 is not less than itself. It's equal to, but we don't have that option. There is no bar here below the inequality symbol. So it's not true. 30 itself is not a solution to the original inequality. The next one, we have a fraction, and this fraction is negative, and it's multiplying our variable. We want to get rid of this fraction. So what we do is we multiply both sides by the reciprocal of the fraction, a negative 3 over 4. Okay, for the reciprocal, the sign stays the same, and we just flip the numbers of the fraction. So, negative 3 over 4 times a negative 4 over 3 just results in a positive 1 in front of the x, multiplying the x. On the right, 6 times a negative 3 over 4 would be a negative 18 over 4. A 1 times x on the left is simply an x. Okay, and another thing I need to do is reorient my inequality symbol, because we are dealing with the operation multiplication, and we did multiply by a negative 3/4. So I split the inequality symbol towards opening up towards the left now, and I can simplify the right hand side by dividing both numbers by 2, and I get a negative 9 over 2. So anything greater than negative 9 over 2, and that would include 0 and any positive number. So any positive number that you plug in to this inequality will satisfy it. Example 8, a two-step inequality. We have 6u plus 5, and just like an equation, we want to get the variable by itself. So with the 6u plus 5, we have two numbers to get rid of. We start by getting rid of the 5. So we do the opposite and subtract 5 from both sides. Here we started with a plus 5, so we subtract 5. 5's cancel on the right. Negative 19 minus 5 is a negative 24. We only subtracted, so we do not reorient our inequality. And now we divide by 6, but we did not divide by a negative number. We divided by a positive number. And so still we do not reorient our inequality. We keep the less than equal to. The 6 cancels on the right, and we bring the u over by itself on the right, and negative 24 divided by 6 is a negative 4. So anything greater than or equal to negative 4 will satisfy this inequality. If we tried negative 4 itself, Okay, we plug negative 4 in the place of u. On the right, we would get a negative 24 plus 5. A negative 24 plus 5 is a negative 19. And we have the option of being equal to the left-hand side, and so negative 4 satisfies the inequality. And so would any other number greater than negative 4, and that would include negative 3, negative 2, negative 1, 0, and any positive number. Example 9, two-step inequality. Here we have a negative 5 and a negative 2. With respect to the x, the 5 is being subtracted with the negative sign in front, and so we add 5 to both sides. The 5 cancels on the right. 21 plus 5 on the left is a 26. To get rid of the negative 2, we have to divide both sides by negative 2, and we'll have the x by itself. However, on the next line, we must flip the inequality to where it opens up towards the left now. We bring the x down on the right. 26 divided by negative 2 is a negative 13. And here we have our solution. Okay, so we divided, and the number we divided by was a negative number. So we had to flip the inequality. Example 10, two-step with fractions. Okay, we have a 2/9 and it's negative. So we do the same thing we would if we had an equation with fractions. We multiply by the lowest common denominator, 9. Negative 14 times 9 would be a negative 90 plus 36. So we get a, what do we get? 126. Okay, we multiplied by a positive number, and so we keep the inequality opening up towards the right. The 9 on the right side is going to multiply the negative 2/9 and the negative 8. With the 2/9, the 9 on the bottom is going to cancel out with the 9 that it's being multiplied by, so we end up with a negative 2x for this term times 9. Then we multiply negative 8 times 9, giving us a negative 72. Okay, so since we multiplied by a positive number, we did not flip the inequality. Now, here's our x on the right. We have a negative 2 and a negative 72 along with it. We get rid of the 72 first by adding 72 to both sides. 72 cancels on the right. We bring down the negative 2x. Negative 126 plus 72 would be, let's see, 28, and a 26 would give me 54. And it would be negative. Now, to get the x by itself, we note that it is being multiplied by negative 2. The opposite of multiplication is division, and to get rid of the negative 2, we divide by negative 2. And so here we are dividing by a negative number again. We flip the inequality symbol in the next line. We bring down the x by itself because the negative 2's cancel, and a negative divided by a negative will be a positive number, and we end up getting 27. So x, if you want to write this in a different orientation with x on the left, note that the inequality symbol opens up away from the x, and so when you flip the x to the left side, you have to flip the inequality around. This may be the easier version to read. X is less than 27, and so we're talking about numbers like 26, 25, in any negative number. 27 itself would not be a solution because we do not have the equal to bar. So just like equations, here we are with a more complicated inequality where the variable is in several places, and there's actually a variable term on each side of the inequality. So first thing we want to do is to combine the like terms from the left and the right side, and since they are on opposite sides, we have to do the opposite of the sign of the number in front of the variable. So this is a plus 6x. To combine it with the 9x on the left, we have to subtract it. Plus, minus, opposite. So the 6x cancels on the right. We bring down the negative 2 to the next line. We were simply subtracting, and so we do not need to flip the inequality symbol. 9 minus 6 is 3 with an x, and we bring down the negative 14. To get the x by itself, we need to get rid of the 3 and the negative 14. So we add 14 to both sides. Cancels on the left. We bring down the 3x. Negative 2 plus 14 is 12. We divide by 3. 3's cancel, and so we get x by itself on the left. We divided, but 3 was positive. We keep the orientation of the inequality, and 12 divided by 3 on the right is 4. Example 12, slightly more difficult in the sense that we have parentheses, and when that happened in dealing with equations, we distributed. That was the first thing that we did. And so with no parentheses on the left, we just bring down the 3v minus 29 to the next line. The negative 2 was already here in the expression. We didn't add in this negative 2 ourselves, and so we are multiplying by negative 2 on the right, but we do not flip the inequality symbol. This negative 2 was already a part of this expression, and so we distribute it. We get a negative 4, negative 2 times 2, then negative 2 times negative 4 results in a positive 8 v. We have v's on each side of the inequality. I will move the smaller number. Okay, 3 is smaller than 8, and so what I'll do is I'll move the 3v by subtracting it. 3v cancels on the left, and I bring down a negative 29. Okay, and so I have a positive number in front of my v. That way when I go to divide, I won't have to flip the inequality. But v's only on the right side now, and so I merely want to get rid of the negative 4 and the 5. And first thing we do is we add the 4. 4 cancels on the right. This inequality leads to negative 25 on the left. I only added, so the inequality keeps the same orientation. And 5 is multiplying the v. I want the v by itself, so I do the opposite and divide by 5. And you only look at the number that you're dividing by. Okay, we're dividing this negative 25 on the left, but we're dividing by a positive number. So I do not flip the inequality symbol here. It's only the number that you're dividing by. So we get v by itself on the right. Negative 25 divided by 5 is a negative 5. And we have the v by itself, so we have the solution to our inequality. Any number less than negative 5, so that would be negative 6, negative 7, negative 8, negative 9. And then we have the equal to bar, and that indicates that negative 5 itself would be a solution to the original inequality. Example 13, inequality with a fraction. We have 4/3. So to get rid of the fractions, we only have one. We just simply multiply everything by 3. Alright. So with the 4/3 times 3, the 3's simply cancel out, and we're left with a negative 4x. So we completed that step, and now we distribute the 3 to the negative 5 as well. That gives us a negative 15. We're multiplying by a positive number, so we do not flip the inequality. Now we distribute on the right side. 3 times negative 8 is a negative 24. 3 times 3 is a plus 9. We have x's on opposite sides of the inequality, and we want to combine like terms. In my policy, you can do it either way. You can add the 4x to both sides, or since we have a negative 4, to get rid of the 4x or combine it to the x term on the right, you would add it to both sides. But I usually move the x term with the smaller number in front of it, and that would be the negative 24. This has the effect of giving me a positive number in front of my variable. So when I combine like terms, I move the 24x to the left. So I add 24x to both sides. They cancel on the right. I bring down the 9 on the right. Same orientation of my inequality symbol. Negative 4 and 24 gives me a 20x. I did nothing with the negative 15. I just bring it down to the next line. And so here we are at a two-step inequality. I want to get rid of the 20 and the negative 15. We undo subtraction before multiplication, so I add 15. 15's cancel. Cancel on the left, and so now on the left I have a 20x. Same orientation of the inequality symbol because I added. So with addition and subtraction, you never flip the inequality symbol when you're introducing addition or subtraction in regards to solving the inequality. 9 plus 15 on the right is 24. And the final step to get the x by itself would be to divide by 20. And we are dividing by a positive number, so once again, we do not flip the inequality symbol. 24 over 20 can be reduced to a 6 over 5 because both 24 and 20 are divisible by 4. 24 divided by 4 is 6, 20 divided by 4 is 5, and so we have the solution to our inequality. X is any number greater than or equal to 6/5. And 6/5 is in decimal form 1.2. So any number bigger than this, or it could be 1.2 itself because we do have the equal to bar in the inequality. Alright, example 14, solve for y and graph the solution. You do not want to graph the inequality until the variable is by itself. And you may be tempted to find -2. Okay, just jump down to the number line and start shading things. But your y variable is not by itself. It has this negative sign in front of it. And so our first step would be to divide by -1 on both sides. The negative signs would then cancel, and that would leave y being positive on the left side. Well, we don't know what number y is, so we can't say whether it's positive or negative, but we no longer have a negative sign in front of the variable, so that's why I call it positive y. But it's less than or better yet, greater than. Okay, y is greater than, because we did divide by a negative number, we flipped the inequality. And so -10 divided by -1 on the right would give us a +10. So we want to graph, the original inequality suggested that we shade to the left because y less than, but that's ignoring this negative in front of the y. And so when we straighten it up, get rid of the negative, we have y greater than 10, so we shade to the right. And we locate a +10 on the number line, shade out to the right, and we're finished. Y greater than 10 to the right. Of 10. Alright, solve the compound inequality and graph the solution on the number line. Well, compound because we have one inequality, then we have another one with a conjunction in between. Alright, so first thing we'll do is we'll take the first inequality, 3x plus 3 less than -9, and we'll solve this. We have to get the variable by itself before we attempt to graph the solution. So, to get the x by itself, our first step would be to subtract 3 from both sides. Negative 9 minus 3 is a negative 12. Then, in the next step, we divide by 3 on both sides, and that leaves x less than a negative 4. Okay, and we divide it by a positive number, so we keep the orientation of the inequality. Now I'll go over here in the space to the right, copy our our second inequality, and I'll go about solving this one, getting the x variable by itself. So first step would be to, I don't know where that 2 came from. We want to add 1 to both sides. So the 1's cancel on the left. We bring down the 4x. We have greater than 19 plus 1, 20. The x is now being multiplied by 4. We do the opposite and divide by 4. 4's cancel, and we get x is greater than 5. So we want to graph the solution, but we can't just graph each one before interpreting these two along with the conjunction or. Okay, and or simply states that we want to shade anything that is a solution to one inequality or the other. It doesn't have to be a solution to both. It only has to be a solution to one or the other. Okay, so what we'll do to be careful about graphing these on the same number line is I'll graph one with an arrow on the top, and then I'll graph one with the arrow on the bottom. So the first one is x less than negative 4. I locate negative 4, and I put an open dot because we do not have an equal to bar in the inequality symbol. Less than negative 4 is to the left. Left is less. Alright, so I shade to the left. And when you say left is less, you always want to orient your inequality to where the variable is on the left. Okay, if I were to do it this way, I'd have to flip the inequality. Okay, and this is negative 4 greater than x. Okay, but the variable x is less than negative 4. So to read it with respect to the variable, we read from right to left. So left is less. We shade to the left. Either version of this inequality, we shade to the left. Now we graph the other one. X is greater than 5. And these shaded regions are not going to overlap. Okay, so we don't really need to put the bars on the top and the bottom. And by the talking about the arrows to indicate the shaded region. I started out thinking I was going to do it this way and just draw an arrow over the top of the part of the number line that was supposed to be shaded, but instead I just shaded it. Okay, but if you understand the meaning of or, then you should know that you pretty much just take both inequalities and dump them on the number line. Okay, because if if the number on the number line satisfies either one of them, then you keep it. So x greater than 5, we'd put an open dot at 5, no equal to bar. Greater than means that we shade to the right. So for a full solution, this would be it. This number line with the left of -4 shaded and the right of 5 open dots at -4 and 5. This is the solution. Okay, we don't have to change anything about it. And that's typical when you have a compound inequality that has the conjunction or. So example 16, we have a compound inequality, and I simply want to point out that sort of written differently, we have an expression involving x, it's less than 2, and it's greater than or equal to 22. This can be rewritten as 22 less than or equal to 4x plus 2. And then we can write 4x, we can repeat this, we can split it up into two inequalities, and so we write the 4x plus 2 again, less than 2. And whenever the inequality is written this way, there is understood to be a conjunction of and that relates the two inequalities together. Alright, so we start out solving each inequality. Minus 2, both sides. 2's cancel. We have 20 less than or equal to 4x. Divide by 4 on both sides. 4's cancel. And we're left with x is greater than or equal to 5. For the other inequality, we subtract 2 from both sides. 2's cancel. We're left with 4x less than 0. Now we divide by 4. And we get x is less than 0. Well, let's graph these two inequalities. We have an open dot for x less than 0 because we do not have the equal to bar, and we shade to the left. And then for x greater than or equal to 5, we have a solid dot at 5 because we do have the equal to bar. And x greater than 5 is to the right of 5. So I usually read my inequalities with respect to the variable. Okay, here I read from right to left. X inequality opens up towards the x, so I'd read greater than equal to 5. If that's hard for you, then just simply flip the inequality. X on the left, 5 on the right, and then flip the inequality. X is greater than or equal to 5. So we do shade to the right, and we want the numbers that satisfy both of these shaded regions, but they don't overlap. And so the solution to this inequality would be a blank number line. There is no number that satisfies this original inequality. If I put in, well, let's just pick a number. If I put in 0, okay, 4 times 0 plus 2 would just simply be 2. And 2 is not less than itself, and so it doesn't satisfy that inequality. And it doesn't satisfy the other one either. 2 is not greater than 22. Okay, and it will not work for any other number because these two inequalities do not overlap. No solution. Because there is no overlap. And we're only looking for overlap when we have the conjunction and or the inequality is written this way. Alright, another inequality here. What we'll do is we'll try to solve it a different way, probably a way that you'll see on Alex, and it's really just comes down to a different style. What we're going to do is take this entire inequality and multiply each, the left, the middle, and the right by 2, because we have a fraction. We want to get rid of the fraction, so we multiply all three parts by 2, so 2 times negative 4, and this is all to get rid of the 2 on the bottom in the middle. 2 times negative 4 is a negative 8. The whole purpose of multiplying by the 2 cancels out in the middle, and we just get left with 3x plus 10. 2 times 5 is 10. Now, before we've only had one inequality symbol, but now we, in regards to our expression involving x, we have one on the right and the left, and so there's really 3 sides here. There's a left, a middle, and a right. The goal is still to get the x by itself, so we want to get rid of the 3 and the 10. The first step would be to subtract 10. So I subtracted in the middle, but now I have 2 other sides to subtract it from, the right and the left. So the 10 cancels in the middle. I'm left with 3x, a less than symbol on the right. 10 minus 10 is 0. Okay, bring down the inequality on the left. Negative 8 minus 10 is a negative 18. Now to finally get the x by itself, we divide by 3 for the left, middle, and the right, and that leaves us with a negative 6 less than x less than 0. 0 divided by 3 is 0. So this is sort of 2 inequalities combined with the conjunction and. Negative 6 is less than x, and x is less than 0. So we sort of repeat this middle part, x, x. Okay. Do these overlap? Well, let's plot the first inequality, and we go to a negative 6 and we put an open dot. Okay, and we want numbers greater than. With respect to the x, the inequality opens up towards the x, so I want x greater than or to the right. And then for the other inequality, we want numbers less than 0. Open dot because there is no equal to bar here below the inequality, and less than 0 is to the left. Now, in combination, these 2 inequalities cover the entire number line, but we only want the shaded part. We only want the overlap, and so anywhere we do not see a line on the top and the bottom, we erase the arrow. So we only get these numbers in between. 0 and negative 6 are not a part of the solution because they're left out of their own inequalities. So as a final solution, we would keep the open dots and just simply shade in the middle. Open dots at 0 and negative 6. Another way to double check yourself is to pick numbers in each of the 3 parts. We have a middle, so if I pick a negative 3, we have a right side, so I could pick a positive 3, and we have a left side, a negative 7. If you forget what the conjunction means or which one you're dealing with, you simply have to pick these three numbers in the three different areas and test them with respect to the original inequality. Does a negative 7 satisfy this original inequality? Plug it in. Three times negative 7 is a negative 21, and plus 10 is a negative 11, and divided by 2 we get negative 5.5. Well, it is less than 5, check, but is it greater than negative 4? And the answer would be no. So negative 5.5 doesn't satisfy both inequalities, and therefore negative 7 would not be a solution. So this part of the number line shouldn't be shaded. And so if you check the 3, it won't check out either. And so that should indicate that this part shouldn't be shaded, the far right. The only numbers that are going to work are going to be the ones in the middle. So our last page, some inequality applications. The problem reads, Justin is going to rent a truck for 1 day. There are two companies he can choose from, and they have the following prices. Company A charges $85 and allows unlimited mileage. Company B has an initial fee of $65 and charges an additional 80 cents per mile driven. All right. What mileage will Company A charge less than B? So we take this expression right here, this phrase, convert it to an inequality. That would be our first step. Company A less than Company B. All right. Company A and B, these parts here just reference the charges. So I keep the less than symbol. What are the charges for Company A? That was $85. What are the charges for Company B? $65 plus 80 cents for every mile, and so I multiply 80 cents times the miles. We don't know the miles, so we use X, okay, in its place. And so I've sort of defined a variable here. I say X equals miles driven. Okay, so what number of miles do I have to drive in order to be charged less? Okay, Company A less than B. Alright, subtract 65 from both sides. We are left with 20 less than 0.8x. Okay, now if I divide both sides by 0.8, I get 20 over 0.8 less than 0.8x over 0.8. What do we get here? 20 divided by 0.8. We get 25. So if I drive more than 25 miles, then I should go with Company A. If I drive less than 25 miles, then I should go with Company B. Example 18, a phone company offers two monthly plans. Plan A, there's no monthly fee, but we pay 6 cents per minute for the plan. B, there is a monthly fee of $4.60, but then I turn around and pay 5 cents per minute. What number of minutes? And we'll say X equals number of minutes. Plan A cost at least as much as Plan B. So at least Plan B. So Plan B, or I'm sorry, Plan A would be greater than or equal to Plan B. So now we simply replace our phrases Plan A and Plan B with their actual costs. Well, Plan A, there is no monthly fee, but 6 cents per minute tells us that we take 6 cents, which in terms of dollars would be written 0.06 times the number of minutes. And then Plan B is a flat rate fee of $4.60. And then we pay more for every minute we use 5 cents, 0.05. And we're using 0.05 because this number here that we use for the flat rate of Plan B is in dollar amount. We don't want to use 5 for cents, but then 4.60 for dollars. Okay, we want to convert the 5 cents to dollars, and that would be $0.05. Well, if we're being charged 5 cents per minute, then we would multiply the 0.05 times X in the cost of Plan B. So here's our inequality. Okay, at least at the lowest cost for Plan A, we are equal to Plan B. So at least as much as Plan B. Okay, when it says at least as much, that means that Plan A could be more than B. So we have variables on the left and right. We want to combine them. I move the smaller coefficient variable term .05x cancels on the right, and then we get 0.01x, 0.06 minus 0.05. That leads us to divide by 0.01 on both sides, and this is the equivalent of multiplying by 100. So what we get is x by itself, self on the left, greater than or equal to, and dividing by 0.01 is the same as multiplying 4.60 by 100, which would be 460. So if the minutes are greater than or equal to 460, then Plan A will cost just as much or more than Plan B. So here is our solution, and that was our last problem of Chapter 21. Thanks for watching.